Now, in encountering variability in the field of engineering and science, suppose that an engineer is interested in designing a nylon connector to be used in an automotive engine. The engineer is considering establishing a design specification in wall thickness at a specific inch or diameter or width or something like that, but is somehow uncertain about the effect of his decision on the connector pull-off force. Now, if the pull-off force is some kind of flow, the connector may fail once it is being connected to this engine. Okay? And for that matter, he made use of, or he came out with an experiment of 8 units. Okay? And their pull-off force is being measured. Now remember, he did for 8 connectors, so we are going to have 1, 2, 3, 4, 5, 6, 7, 8. Now for the first observation, he had a pull-off force of 12.6. Next one happens to be 12.9, 13.4, 12.3, at 13.6, 13.5. Then 12.6, and lastly 13.1. Okay. So with this data set, you can see that these data set, their forces are always not the same, which is an indication that there's a bit of variability in that. Okay. So in order to determine this level of variability, the variance and the standard deviation happens to be some significant parameters or statistics that you can use. Okay, so in determining the variability, let's try to estimate the variance as well as the standard deviation for this data set that we have. Okay, now remember, once it comes to the standard the variance, remember this is just equal to 1 over n minus 1 summation from I equal to 1 to n, then xi minus x bar whole square. And that of the standard deviation, which happens to be this, is just equal to the square root of variance. Okay, this that. Now let's look at this. Okay, you could have solved this using how we solved it earlier. That is, let's say you take the first observation minus that over the mean. Okay, but it looks more appealing once you try to solve this in the table. Okay, now with this formula. Looking at this, all that we need is to find the difference between the x, each observation, as well as their mean. So our first point of call will be to estimate this mean. Okay? Now, in estimating this mean, let me try to divide this into 2. Now, let's denote this our variable by x. Okay? So in determining the mean of this x, which is the same as 1 on n summation of xi equal to 1 to n. Okay, so just the normal estimation of the mean. Okay, and once you go through all this is going to lead us to the mean of where is going to lead us to what 13. Okay, so now all that we have to do is try to estimate this term that we have in here. Okay? So in doing so, it means that we need the difference between each xi and the mean. Okay? And that can be represented as xi minus x bar. Okay? That's right. And this will be one column. Okay? Now in doing so, the first one will be 12.6 minus the mean, which is what? 13. Okay? So the first one is going to be negative 0.4. The next one, negative 0.1, 0.4, negative 0.7, negative 0.1, maybe just was 3, 6, 5, then we have negative 0.4, then final 0.1. Okay? Now remember that before we get all this summation, we need to square this term that we have here. Okay? So this is the same as xi minus x bar all squared, and that is just going to give us what? This whole n. Now, if you should square this is giving us 0.16. The next one happens to be 0.01, then 0.16, 0.49, then 0.36, 0.25, then 0.16, 0.01. Okay, so this happens to that. Now let's get to estimate our summation. That is the whole of this term. And in summing everything that we have here, this will give us 1.610, and that will be our summation. Okay. 1.60. So with this value achieved, all that we have to do now is just substitute this value to replace this whole term. Then we find this and that. Okay. So in estimating for the variance, this will equal to 1 over n minus 1. Remember, we have our observations to 8. So 8 minus 1. Then all times the summation of this, which we've calculated to be 1.60. So this will be 1.60. Okay. And once we estimate all this, we are getting a variance of 0.2286. Okay. Now, with this variance, we can use this to also estimate our standard deviation. And remember, our standard deviation, which is the same as the square root, the square root of the variance, will be equal to 0.2286, and this leads us to 0.48. Okay. Now, let's see how we get to discuss this or report on these values that we have. Now you can see that with our mean, we are having a mean of somewhere 13, and we are having a variance of 0.286. Now if you should compare the mean to this variance, you can see that it is very small. Okay, so this implies that the variability, although there exists variability in there, but this is not so great from the mean. Okay, so meaning that if we were to estimate for our next pool of forms, the deviation from the known mean, or this mean that we know, wouldn't be so much great. Okay, so that is the practical implication of how to determine this variability once it comes to our data sets. Okay, now similarly, if you look at the standard deviation, that is in general, if we are to take all the deviations in general, you see that this is also somehow not close to 30. Okay, so with this data set, the variability although is there, but it's not so much. Okay, so that is that. Now, one thing that you should also know is that with this data set is small, but in real life situations, we can have something which is much more complicated than this. Okay, now especially when you get to be dealing with numbers with so many decimal places, estimating this becomes so much tedious and all that. So there's also an alternative for coming up with a simple, or let's say a shortcut formula to this whole expression that we have here. Okay, so with this shortcut formula that we are going to derive very soon, you really need to make or get all of these parameters before we can estimate our final variance. Okay, so let's see how we get to do this. And remember, this is in your lecture material. That will be example 2.12 on page 31. Okay, all these have been solved. So let's get to see how we come up with our shortcut formula. Okay, and it's so easy. So remember, this formula will be derived using the variance formula. I remember the variance is equal to 1 over n minus 1. Then remember summation from I equal to 1 to n times or xi minus x bar all squared. Okay. Now let's do a little bit of mathematics in here. Now, if you have something like this, okay, let's try to expand this part of our term of our equation. Now, so this will be equal to 1 over n minus 1, and let's try to expand what we have in here. Okay. So in expanding, this will be equal to xi squared plus x bar squared, then minus 2xi, then x bar. Okay? So this is the expansion of this term that we have right here. Now, let's try to multiply through by this summation symbol that we have. So this will go 1 over n minus 1. Then summation I equal to 1 to n. So the first term will be xi squared plus summation xi 1 to n. Then remember, because this is a constant, if you are trying to sum all this, it's kind of not possible because we don't have that iterative element in there. But because we are summing from 1 to n, this is the same as n times x bar of everything that we have there. So we are going to find this one, n times, okay? Minus, let's bring for the last term, we are just going to bring the constant out, x bar. Then remember we have an iterative term in there. So this is just going to be 1, okay? And that gives us 1, yes. Now, remember from our previous discussion that our x bar is equal to 1 over n summation of all xi, where I is starting from 1 to n. Okay? So let's try to find a way of just substituting this with all the x bars that we have in there. Okay? So this will be equal to 1 n minus 1. Remember, we have summation I equal to 1 to n, then xi squared plus n. Then in place of our x bar, we are just going to put the whole of this formula there. So this becomes 1 on n summation from I to 1, I of 1 to n times xi. Now remember, everything we have here is being what? Squared. Minus 2 x bar, which is equal to 1 over n, summation of I equal to 1 to n on all xi. Then finally we have x, summation of xi. Okay. So this is the final term that we have. Okay. Now with this, let's try to simplify this further. Okay. Now this is just going to be 1. Let me make this bigger. N minus 1. For this part, we can do a little about this. So this is just going to remain as it is. Xi squared. Now let's look at this aspect of it. Now with this aspect, we can think of bringing this constant out. Okay? And remember, this is squared. So we have to bring this out. And bringing this out, this is going to be n into bracket n squared. Because of this square will still remain, and the rest follows. That is xi to 1 and xi. Now remember, all this is in what? Squared. Okay, don't forget that. The minus. Now with this aspect 2, we can bring this constant out. So this becomes 2 on n, then summation of I to 1 n of xi, and we also have another one in here, xi as a result. Now with this can cancel one of this, leaving only 1, and looking at this again, if you should multiply this and this is going to be 2y squared, okay? Because this and this can be multiplied together. So this becomes 1 all over n minus 1, okay? Then we have summation of xi from I running from 1 to n. And remember, this is squared. Plus, remember, this cancels one of this, so this is just going to be 1 on n. Then summation of xi, all this is b squared, minus our 2n. Then finally, once we multiply these 2, this also becomes summation of I equal to 1 to n of xi or squared. Now, looking at these two parameters or these two terms, we can subtract this from this, and it's possible. Now, once we do that, this is just going to yield 1 on n minus 1 to bracket summation of I equal to 1 to n of xi squared. That is the first term. Now, once we subtract this from this is just going to be 1 on n. Remember, this is 2 and this is just 1, okay? But the dignity is 2, so it means that whatever is being made in there will be 1 minus. So minus 1 times the summation of xi to 1 and everything is squared. Okay? So, as a way to simplify this, the whole of this expression, or our new variance that we are trying to come up with, which happens to be the shortcuts, will be equal to summation of xi squared from I running to 1 to n minus 1, or should I say summation I equal to 1 to n of xi all squared. Remember, this is divided by n. Then after, the whole of this is divided by n minus 1. So this happens to be our shortcut formula. Okay? So with this, you can see that we'll be able to take away all the x bars out of this formula. So once you have this expression, all that you do is just the square of the variable that you are looking at, and as well as after you've been able to estimate the total of this, you just find the square of it, and voila, we are done. Okay? This is a little bit shortcut. Okay? So let's try to demonstrate the same using the polar force example that we have. Okay? So I believe I can clear this portion. So this is the only formula that we need for now. Okay. So for us to determine this shortcut formula, all that we need is just the square of this x. Okay. And we just find the total of all this, then we just square it. Okay. So let's try to estimate this. Now in doing so, it means that we have to take each xi and just square the xi. Okay. So it means that we are just finding another parameter. In this case, we are not going to need all this. So suppose that this happens to be a very fresh question. We don't need all this. All that we do is just how to estimate the xi squared. Okay. So with this, we just take each variable or each value that we have here and just square this. So in this case, the first term, or the first parameter, the variable, that is 12.6 squared. This is going to give us 158.76. This one is 166.41. We have 179.56. This one we have 151.29, we have 184.96, and we we have 182.25, we have 158.76, then finally we have 171.61. Okay? So to find the summation of xi squared, this will be equal to summing the whole of this. Okay? And this gives us 1353.1, just 6. Okay? Now remember, at the end of the day, we also have to find the summation of this xi. Remember, this is only xi, okay, which happens to be the raw data set. Okay? So summation of this xi will be equal to summing everything that we have in here, and which is equal to 104. Okay? So with this, these are all the parameters that we need. Okay? So putting these parameters into our formula, we have our variance to be equal to summation of this I squared, which we calculated to be 135.6. So this will just be 1353.6 minus the summation of xi. Summation of xi happens to be 104. And remember, everything we have here has been squared. So everything we have here is squared. Now remember, divided by what? N. And remember, we have what? N of deviation, that is the deviation we have in there. All over n minus 1, which happens to be 8 minus 1. Okay? So once we do simplify this, we are going to get something similar to what we had earlier, okay? Or something same as the one we had earlier. So in this case, we are going to get, if we should simplify the whole of this, we are getting 0.2286. Okay? And remember, this is just for the variance. In finding for the standard deviation, this is just the square root of everything we have for what? The variance. And this is equal to 0.2286, which gives us what? 0.148. Okay? So the explanation for this is just similar to the first one that we have. Okay? So the difference between the first one and the second one is just the formula. Okay? This is more or less like a shortcut formula. Okay? You don't have to go through trying to estimate the mean, trying to estimate xi minus x bar. Okay? All that you need is just what? This column of theta, that is the xi square, and that can give you the variance and that of what? The standard deviation respectively. Okay?